Okay guys, so here's a quick video just recapping some basic rules of probability that either we have already spoke about or you probably are already aware of. So first basic rule is that any probability is a number between 0 and 1. So the event's never going to occur if the probability is 0, where an event will always occur if the probability is 1. You would notate that as follows. Second basic rule of probability would be that the sum of probabilities of all possible outcomes must equal 1. So let me just show you guys that real quick. So I guess a easy but effective way of doing that would be as if we spoke about tossing a coin. So the probability of tossing a coin and getting heads would be 1/2. The only other possibility there would be tossing a coin and getting tails. And so those are your two possible, or your two probabilities in such a situation. So 1/2 plus 1/2 is 2/2, and there is that 1. Okay, so this is pretty much just a formula to follow that the probability of an event will equal the number of outcomes for that event over the total number of outcomes. So you'll usually hear like favorable outcomes over total outcomes. Okay, so now let's talk about complements. So the probability that an event does not occur is 1 minus the probability that the event would occur. So if they have to total 1, then if you subtract the likeliness of it occurring, you would have the likeliness of the event not occurring. Okay, so this is often referred to as the complement rule. It would be notated as follows. So let's talk about a little bit of an example for that one. So again, probably easy, but effective in any case would be something like, let's say we're rolling a die, and we want our outcome is not a multiple of 3. Okay, so there's a few different ways that we could think about this. First, we could think about what the multiples of 3 are. So the multiples of 3 are 3 and 6 on a die, and so the ones that are not a multiple of 3 would be 1, 2, 4, and 5, and then this would be our sample space here, and so our probability that we would roll a number that is not a multiple of 3 would be 4/6 or 2/3. Okay, we could, however, have used 1 minus the probability of the event occurring. So 1 minus the probability of getting a multiple of 3 on a roll of a die would be 2/6, the 3 or the 6. And then that would be 6/6 minus 2/6, and there is that 4/6 again. Whoops. Whoops. Okay. Okay, next basic rule. If two events have no outcome in common, the probability that one or the other occurs is the sum of their individual probabilities. So this rule is known as the addition rule for mutually exclusive events. So these things have nothing in common. They would be referred to as being disjoint. So there's no overlap between A and B. And just for the sake of kind of review of probability, the word or would mean to add with probability. So let's take a look at an example there. So Non-mutually exclusive events could be something like um, rolling a die. So let's go back to uh, rolling a die and rolling a 2 or a 5. Okay, there's no overlap. There's 1 2, there's 1 5, there's a no overlap. You can't possibly roll a 2 and a 5 at the same time if you're rolling one die, that is. So, so you would have 1 out of 6 plus 1 out of 6, and so there's your probability for rolling a die and getting a 2 or a 5 because those are mutually exclusive events. Okay, so maybe a little bit more complicated would be something like a deck of cards. Okay, so in a deck of cards, the probability of drawing a black card or let's say a diamond. Okay, so in a deck of cards, you have 13 spades and 13 clubs that are black, so that's 26 out of your 52, okay? And diamonds are red, they're never going to be black, so you'll never have an overlap, they don't have anything in common. There are 13 of each suit, so there's 13 diamond, and so 39 out of 52, or 75%, or 3/4, however you want to express your probability. Okay, and now I believe is the last rule for now. If two events have outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities minus any overlaps or double counting. Okay, so this would be known as the general addition rule for two events. These events are considered non-mutually exclusive, meaning they have something in common. There is an overlap. If you don't subtract something, don't take that into consideration, you're going to be counting something more than once. So in symbols, it would look like this. You should concentrate on the kind of formula here to follow. So the probability of A or B, if they are non-mutually exclusive, you add together the two and then subtract your overlap. Okay, so let's look at a quick example of this. I guess we'll go back to a deck of cards because there's a lot of overlap there. So let's talk about the probability of a black card or a spade. Okay, so I already said in the last one, you have 13 spades, and spades are always black. So you obviously know that you're going to have an overlap here between the two. So what this is telling us to do is take the probability of it being black, add it with the probability of being at a spade, and then subtract the probability of being both black and a spade. Okay. And so you have 26 out of your 52 cards being black, 13 out of your 52 cards being spades, and you already accounted for those 13 cards in that 26. So you have to take those back out, and so you're back down to, obviously, your 26 out of 52. Okay. Let's look at some examples. Okay. So, distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. Here is the probability model. Show that this is a legitimate probability model. So we have to know that all of these 4, probabilities must total 1 for it to be um, a proper probability model, and they do, so it is good. Then find the probability that the chosen student is not in the traditional college age group, so 18 to 23 years. So you're looking for it in two ways. You can either add together the 24 to 29, 30 to 39, and 40 and over, okay? Or you could take your 1 and subtract your 18 to 23. That's what I do because I think it's a little bit quicker. And so there is your answer. And now a check your understanding, which you have your questions on already. So as usual, you should probably pause it, find your answer, and then play it so you get your answer. Okay, so here's the answer to your first one. Here comes the second one. So look at it, pause it, answer it. Here's your answer. Here's your next question. And answer. Sorry. Okay. Another check your understanding. Do the same process. Get your answers. Pause it. Get your answers. And then play it for your answer. Okay, guys, so that's it. And we will practice problems when we get to class, next class.